today is Katie Barron. She is from Kingsport, Tennessee, graduate of Sullivan North, a cell and molecular biology major. She is pre-pharmacy. In fact, she, as a neonate, got a perfect score on her APGAR and is now going to be attending the Gatton School of Pharmacy next year at ETSU. Her talk is somewhat related to what we just saw, talking about methylphenidate and drug abuse.
Okay, I'm going to be talking about methylphenidate treatment during adolescence and whether or not it increases the rewarding effects of cocaine during adulthood. So methylphenidate is a drug that's commonly used to treat ADHD. So I'm going to start by talking a little bit about what ADHD is. It's short for Attention Deficit Hyperactivity Disorder and is characterized by a number of symptoms such as an inability to focus or to sit still for long periods of time, and also by extreme hyperactivity and impulsivity. This is also a very commonly diagnosed disorder, affecting approximately 5 to 12% of children, with about twice as many boys as girls being diagnosed with the disorder. And the exact biological causes of ADHD are still somewhat unknown, but it's believed that it's caused by imbalances of the neurotransmitters serotonin, dopamine, and norepinephrine in the brain. The most common form of treatment for ADHD is the use of psychostimulant medications, which these drugs act to alter the transmission of neurotransmitters in the brain. And the three most commonly prescribed are methylphenidate, which is the one that I will be looking at today, and it's sold under the more commonly recognized names of Ritalin and Concerta. And the two other most commonly prescribed are dextroamphetamine, more commonly known as Adderall, and lisdexamphetamine, which is Vyvanse. Children who have been diagnosed with ADHD are more likely to develop drug abuse problems as adults, and a study by the Centers for Disease Control has shown that approximately 25% of adults who are in rehabilitation for substance abuse problems have been diagnosed with ADHD at some point in their life. And many people believe that this correlation is caused by the treatments that they received for their ADHD when they were children. So my hypothesis is that methylphenidate treatment during adolescence increases the rewarding effects of cocaine during adulthood. The first study that I'm going to be looking at is by Harvey et al. And this study used rats with an ADHD phenotype to evaluate the effects of methylphenidate use during adolescence on cocaine addiction vulnerability and on dopamine transporter function. This study used 3 different strains of rats. The first they used were spontaneously hypertensive rats, which is shortened to SHR in this study. And these rats were used as their ADHD model. And these rats are commonly used for this purpose because they have been shown to have deficits in learning and memory that are similar to symptoms of humans who have ADHD. The other 2 strains of rats that were used were Wistar Kyoto rats and Wistar rats, and these 2 strains are just used as control groups, mainly just to represent people who do not have the ADHD disorder. These rats first went through a pre-treatment procedure during which all 3 strains were divided into 2 groups. The first group received daily treatments of 1.5 milligrams per kilogram of methylphenidate, and the second group received treatments of just tap water, which was the vehicle treatment. and these treatments were given orally. The methylphenidate was dissolved in tap water, and it was injected into a cracker and then fed to the rats. And the vehicle treatment was simply tap water injected into a cracker. This treatment lasted for 4 weeks. It was done 5 days a week, with the rats receiving no treatments on Saturdays or Sundays. The first test that was done in this study was a visual discrimination test, and they used this test to justify their use of the SHR rats as an accurate ADHD model by identifying deficits in learning that could be improved with the use of methylphenidate. And for this test, the rats were placed into a maze, and they were given a chocolate-flavored pellet for every correct turn through the maze. And these rats were said to reach criterion level after they could successfully complete the maze 10 times in a row while receiving rewards, and then one additional time with no rewards. Surgery was then done to each of the rats to insert a catheter into the jugular vein, and this was done so that cocaine could be delivered through the following experiments. The first test was a self-administration test, and for this, the rats were given the option to press either an active or an inactive lever. The active lever would deliver a 0.3 milligram per kilogram dose of cocaine, and the inactive lever would deliver no dose of cocaine. And these rats reached self-administration criterion after they pressed the active lever 20 times within a 2-hour session for 2 days in a row, and they also had to press the active lever at least twice as many times as the inactive lever. The next self-administration test that was done to find progressive ratio breakpoints, which was basically looking at how far the rats would go to receive a cocaine injection. And for this test, the rats would receive an injection of cocaine after they pressed the active lever a certain number of times. And after each injection of cocaine, the number of times they had to press the lever to receive the next cocaine injection would increase by an exponential amount. So if they had to press the lever 2 times to begin with, they would have to press it 4 more times before they would receive the next cocaine injection, and then 16 times after that, and it would just continue to increase until they reached the breaking point, which was when they did not receive an injection of cocaine within 60 minutes. They then performed a dopamine uptake assay, during which they obtained 8 new rats of each strain and subjected them to the same methylphenidate pretreatment procedure as the previous group of rats received, which was just where they received the daily doses of methylphenidate for 4 weeks. And at the end of that 4 weeks, they removed the prefrontal cortex and the striatum from each rat and performed an assay to determine the rate at which dopamine uptake was occurring in each part of the brain. For the visual discrimination test, when the rats were given the vehicle pretreatment, the SHR rats required a significantly higher number of trials than either of the other strains to reach criterion level, which did indicate that they had a deficit in learning. And when they were given methylphenidate, the number of trials they required to reach criterion decreased, which did show that their performance was improved by the use of the methylphenidate. For the self-administration test, the rats who had been given the vehicle pretreatment required fewer trials to reach criterion level than either of the other 2 strains. And when they were given methylphenidate, this further decreased the number of trials required. So they acquired cocaine self-administration more quickly than did either of the other strains that were used. When the rats were given the vehicle treatment, the breakpoints did not vary significantly between the three strains. The SHRs did have slightly higher breakpoints, but this was not considered to be a significantly higher number. And when they were given methylphenidate, the SHR rats did have significantly higher breakpoints, and they had higher breakpoints also at higher doses of cocaine, whereas the methylphenidate treatment did not seem to affect the other two strains at all. The results for the dopamine uptake assay were given as a percent of uptake, and it was given as a percent of the control, and the control was just said to be the normal rate of uptake in rats who had not received any kind of methylphenidate treatment, and this was given to be 100%. Anything below 100% was considered to be a slower rate of uptake, and anything higher than 100% was said to be a faster rate of uptake. And when the SHR rats were given methylphenidate, their rates were below 100%, so they did have diminished rates of uptake, whereas the other two strains were above 100%, so they had slightly higher rates of uptake. And in the striatum, the methylphenidate treatment did not seem to affect dopamine uptake because all three strains were consistently around 100%, which was just the normal rate of uptake. The second study, which was by Crawford et al., was done also to evaluate the effects of methylphenidate treatment during adolescence on the rewarding effects of cocaine. And this was done using two different types of self-administration tests, as well as a conditioned place preference test. This study used 209 male and female rats, and these rats were divided into three groups for the pre-treatment procedure. The first group received daily injections of saline. The second group received daily injections of a 2 milligram per kilogram dose of methylphenidate, and the third group received a higher 5 milligrams per kilogram methylphenidate dose. This pre-treatment was done for 10 consecutive days. And the first test that was done was a conditioned place preference test. And for this test, they used a chamber with two different sections, a black section and a white section, with a divider in between the two that could be removed or left in to separate the two compartments. And this is just a picture of the device that they used for this test. The rats first went through an acquisition period during which they were given daily injections of either 10 milligrams per kilogram or 20 milligrams per kilogram of cocaine, and then placed into the white compartment for 30 minutes, or they were given injections of saline and placed into the black compartment. And this acquisition period lasted for 7 days. And at the end of this period, they were given a place preference test, during which they were given free access to both the black and white compartments, and they were given a place preference score, which was determined by the amount of time they spent in the white compartment. They then went through an extinction period, during which they only received daily injections of saline, and they were placed alternatingly between the black and white compartments. And this period lasted for 8 days, after which they were subjected to a second place preference test. And then there was a reinstatement day where all of the rats received a 10 milligrams per kilogram dose of cocaine and were given a third place preference test. For the self-administration test, this was done in 2 different ways. The rats received a cocaine injection after they pressed the active lever a certain number of times, and the way this was done was similar to the way it was done in the previous study that I looked at. And they were divided into 2 groups. One group, when they pressed the active lever, received a 0.25 milligrams per kilogram dose of cocaine, and the other group received a higher 0.75 milligrams per kilogram dose. This was done on both a fixed ratio and a progressive ratio schedule. For the fixed ratio, the number of times the rat had to press the active lever to receive a cocaine injection did not change throughout the entire experiment. And for the progressive ratio schedule, this was similar to the progressive ratio test done in the previous study, where the number of times they had to press the active lever increased at an exponential amount with every cocaine injection they received. And again, testing was stopped after 60 minutes without the rats receiving a cocaine injection. The results for the condition place preference test are divided up between the acquisition period, the extinction period, and the reinstatement period. And a place preference score was given for each period. A negative place preference score indicated that the rats preferred the black compartment, where a positive place preference score indicated that they preferred the white compartment. For the acquisition period, rats who had been treated with cocaine did prefer the white compartment, and they had very high place preference scores, but these scores did not differ between the 2 different doses of cocaine. After the extinction period, only the rats that had been pretreated with methylphenidate showed any preference for the white section, but this was not determined to be a significant preference because the place preference scores were very low. And on the reinstatement day, the rats that had been treated with cocaine did again prefer the white compartment, and the rats that had been previously treated with the higher cocaine dose showed a higher place preference score, even though on the reinstatement day they had all received the same dose of cocaine. However, for none of these place preference tests was there any difference between the methylphenidate and the saline pretreated rats, which suggests that methylphenidate did not affect the condition place preference tests. For the fixed ratio self-administration test, the results for this were divided up between the males and the females. And for the females, they received more cocaine infusions at the lower cocaine dose than at the higher cocaine dose. And there was no difference between the methylphenidate and the saline pretreated rats for either of those cocaine doses. However, for the males who had received the methylphenidate pretreatment received more cocaine injections at the lower cocaine dose than at the higher cocaine dose. And the progressive ratio test was divided up the same way between the males and the females. And again, for the females, there was no difference between the methylphenidate and the saline pretreatments, but there was for the males. The males who received the methylphenidate pretreatment received more cocaine injections at higher doses of cocaine, and they also consistently received more injections than the saline pretreated rats. So again, my hypothesis was that methylphenidate treatment during adolescence does increase the rewarding effects of cocaine during adulthood. And the conclusion that I came to was that this still may be true, but the data from these two studies alone is insufficient to support the hypothesis. And this is because both studies do seem to show a correlation between methylphenidate pretreatment and increased rewarding effects of cocaine in some situations. In the first study, the methylphenidate pretreatment led to higher breakpoints and also to fewer trials to reach self-administration criterion. And in the second study, the male rats did receive more cocaine injections at certain cocaine doses when they had been pretreated with the methylphenidate. However, methylphenidate was not shown to affect condition place preference results. And also, both studies did use rats that did not have an ADHD phenotype. However, the results for this were different from both studies. The first study showed that these rats were not affected by the methylphenidate, and the second study showed that the male rats were, but the female rats were not. And there are my references. And are there any questions? Yes, Dr. Fitz.
In your second study,
Uh-huh.
did the authors speculate as to whether or not estrogen was protective or whether testosterone was potentially causing the increased result that they saw with the cocaine addiction?
They didn't really specify as to what they thought each one did, but they did say that they thought testosterone and estrogen did affect the results. They didn't say exactly how they thought it did that, though. Yes, Dr.
Can you
Owens.
explain what place preference shows in real world terms? Because I haven't ever heard of it.
The chamber, it had two compartments, and rats normally will prefer the black compartment because they're nocturnal. And if they're given cocaine and placed in the white compartment, which they normally would not prefer, if you put them back in there without the cocaine and they still go to the white compartment, that shows that they've kind of acquired an addiction for the cocaine and that they associate the cocaine with the white compartment. Yes, Dr. Fitz.
What's the normal dose for humans for methylphenidate?
I'm actually not certain. They said that the doses they chose, the lower doses, were used to, were meant to be sort of relative to a normal human methylphenidate dose. However, I'm not exactly sure what that dosage is. I can find out for you.
Do you know what the normal milligram, what the normal dose is that's prescribed? Or what, I mean, what size the pills come in, or I have a couple of students in here I could probably ask as well, but I would really prefer that you answer the question.
Yeah. Oddly enough, we do not have that many people on methylphenidate at work. Otherwise, I would get my information
What's
from
given
that,
instead?
Mainly it's Adderall,
So what's a normal dose for that?
usually around 10 milligrams, I believe.
Okay.
Dr. Graham.
Could you go back to the slide where you're looking at reuptake?
Yes.
I guess there were probably a couple of them.
This one?
Yeah, so what are they concluding from this?
Basically what they were getting from this is just that the methylphenidate use does alter the rate of dopamine uptake.
And so the significance of that for what they're interested in studying is what?
gathered from it was that this may be indicating I'm sorry, I'm not entirely certain.
So, if it's going down here as a result, what's that doing in this area of the brain, and what's that doing in these synapses?
That just means that it's not removing dopamine as quickly as it would in a normal rat that hadn't been given this methylphenidate. So it's basically kind of increasing and prolonging the effects of the dopamine.
And that's, for the rat, that's going to be a positive thing, or that's going to be a negative thing?
It's going to be a negative thing. I mean, the rat's going to believe that it's a positive thing,
Right. But his mom is going to be disappointed.
Yes.
Okay.
Yes, Dr. Allen.
So we're choosing the lesser of two evils, right? One, you have ADHD, or take some medication for the ADHD and risk being, addicted to drugs later in life. So you have other alternatives other than methylphenidate. But if you choose to use methylphenidate, do they actually suggest a different kind of drug regimen on how you take those, spread it over so many days, or take so many doses, different dosages and stuff like that, in order to avoid this particular cliff that you will possibly be addicted to drugs later in life?
No, not that I'm aware of. Actually, from my understanding, people aren't normally even warned about this.
So this is relatively new.
It is.